Alright, this is Mr. Gillum, and today we are going to turn fractions into decimals. Yay! You all love decimals! And I hope you love them as much as you do right now after we're done with this lesson. But all we're doing today is learning a skill that's changing fractions into decimals, and the only thing you need to know is that you're dividing the top number by the bottom number in your fraction. It is literally exactly what a fraction bar represents. The top number is divided by the bottom number. The numerator, or the accidentally put numerator. The numerator, top number, divided by the denominator, the bottom number of your fraction. So, for instance, we'll just do the easiest one I can think of here. Let's just do 3 divided by 2 and 2 divided by 3. Okay, these fractions are different and they mean different things. One's an improper fraction, bigger than 1. One's a normal fraction, it's 2/3. So there's different decimals that go with each of these. 3 divided by 2 would be, 2 goes into 3 one time with 1. Now, since there's no decimal, let's just add 1 on there and we'll carry down our 0. 2 goes into 10 5 times. And then there is no remainder. So I know I can finish because my decimal is going to stop right there. It's going to terminate. So 3/2 is represented by the decimal 1.5. However, 2/3, on the other hand, something much different. And it matters where your numbers are in your fraction. It's like saying 2/3 of a whole. And so when I do 2/3, 3 unfortunately doesn't go into 2 at all, 0 times. So I'm going to put a little decimal after the 2 and continue on. Now, as I have 3 goes into 2.0, I'm thinking really, how many times does 3 go into 20? I know that goes in 6 times. All right, and so now I have to subtract, and I have 2 again. I'm going to bring down my next 0. And 3 goes into 20 6 times again. 6 times 3 is 18, so I'm going to subtract that little fella. Bring down my 2, and I can keep going, 0. And what you're going to notice is we keep getting 20, 20. And so once again, 3 goes into 20 6 times. Minus 18 is 2. And bring down the 0 again. So what's going to happen is I keep getting 6, 6, 6, 6, 6, 6, 6 over and 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 over. And so 2/3 is represented by the decimal 0.6 repeating. It's just 6, 6, 6, 6, 6. It just keeps going on and on and on. Okay, and that's the whole lesson today. Turning these fractions into decimals. It's just long division practice. Okay, but we've been practicing that, so we should be good at it. Let's just start with number 1, 2, and 3. 4/5. Let's say you got 4 out of 5 on a quiz. To find the percent, you would do 4 divided by 5. And unfortunately, we don't have 5 can't go into 4. So I'm going to add a 4.0 in there. I'm going to think, how many times does 5 go into 40? It goes into 8 times. And I'm going to subtract 8 times 5 is 40. So 0 left over. And I don't even need to carry down a 0 because I'm out of remainder. So I know that if I have if I get 4 out of 5 questions right on a test, I know that I'm getting a 0.8 of the questions right, or 80%. But in this case, it doesn't ask us what percent we got. It just asks us what is the decimal version of 4/5, and that would be 0.8. This last 0 is not necessary. We don't need to put him on there. He's just a placeholder if we need him to be. Okay, if I got 3 out of 8 on a test question, we could say, oh, 3 divided by 8. That's what we're thinking. Well, 8 doesn't go into 3, obviously, so we're going to put a placeholder and a 0 in there. How many times does 8 go into 30? 3 times. And 3 times 8 is 24. That leaves us with 6. And so let's just add another decimal in there since I didn't get remainder 0. Now I need to think, how many times does 8 go into 60? 7 times. And so 7 times 8 is 56. And that leaves us with 4, and we bring another one down, 0. And 8 goes into 40 5 times. And 5 times 8 is 40. And now we finally have a remainder 0. So 3/8 is 0.375 as a decimal. Okay? That means if you got 3 out of 8 right on your test, then you got a 37.5%. Now it doesn't say that, but that's honestly, that's what it means. That's how your grades work. So now we have a negative, and the only thing that's going to change about our process here is that our answer is going to be negative. That's it. I'm still doing 5 divided by 6. And once again, 6 does not go into 5, so I need a little placeholder there. Make sure I keep my decimal there. 6 does go into 50. 8 times. 8 times 6 is 48. So you can see where your multiplication facts are going to be very important for this. And when I subtract, I have 2. You want me to show the work there? And so I need to bring down my next 0 because I don't have I still have a remainder. 6 goes into 20 3 times. 3 times 6 is 18. And so once again I have 2. And I'll bring down the next 0, and what I notice is it looks like I'm going to keep getting the same thing over and over again. If I bring down another 0, you see how it's repeating every time by 20, 20, 20. So what I know is I'm going to have negative value for the negative sign. 5, 6 is really equal to negative 0.83. I'm going to put the repeating sign over the 3 because the 3 keeps going and going and going and going and going. Lots of 3's. If I kept expanding my division, I'm just going to get 3 and 3 and 3 and 3 and 3 over and over and over and over and over. Let's take a look at the next one here, next 3. Once again, we just have these nice fractions. They're not improper. If you got 1 out of 9 on your test, that's what it's asking you here. Here's how you find your percent, or how many you got right. Percent you got right. 9 goes into 1 0 times. You can put the 0 up there if you want to remind yourself. So I'm going to have to put a little placeholder on there, 1.0. Now 9 does go into 10 one time. And 1 times 9 is 9, and 10 minus 9 is 1. So I'm just going to bring my next 0 down there, my next placeholder, and once again, 9 goes into 10 one time. 1 times 9 is 9. 10 minus 9 is 1. And I bring down my next 0. And once again, I see this pattern starting to occur. 9 goes into 10 once. 1 times 9 is 9. Gives me with 1. And I bring down the next 0. And once again, I have 10. Okay, so it's repeating again. So 0.111111111. And so 1/9 is represented by the decimal 0.11111111111, and it's going to keep going and going and going and going and going, but I don't need to write it that many times. We're just going to use this little symbol above the first where the pattern starts, and in this case it just starts with the 1, and it just is a repeating symbol. That little like that little dash above it, that just means it's going to keep being the same number over and over and over, or the same pattern or the same frequency sequence. Okay? 3/4. If you got 3/4 of the questions right on your test. 3 divided by 4. Now, unfortunately, 4 doesn't go into 3, so we have a little placeholder there. We'll put our decimal in there and add a 0 for a placeholder. 4 goes into 30 7 times, and 7 times 4 is 28. It leaves me with 30 minus 28 is 2, or if you want to do it this way, 2 minus 2 is 0. And I can bring my next placeholder 0 down. 4 goes into 20 5 times. And so 5 times 4 is 20, and when I subtract the 20, I'm left with nothing, no remainder. So 3/4 as a fraction is represented by the decimal 0.75. And 3/4 of a dollar is 3/4, which is also 75 cents. That's a good way to remember it as well. Or if you get 3 out of 4 questions on the test right, then you've got 75% of them right. Or if you go 3 for 4 in a baseball game, you are batting .750. So a lot of these things apply to many different things. Now, we already did 2/3 and 3/2, but we can do 2/3 again. Ooh, careful. Mr. Gillum almost made a big mistake there. He almost did 3 divided by 2 from bottom to top. Wrong. It has to be top divided by bottom. 2 divided by 3, just like that. Unfortunately, 3 doesn't go into 2, so I'm going to put my little placeholder there. And we're going to say, okay, 3 does go into 20 6 times. 6 times 3, 18. Leave me with a 2. And then I'm going to bring my next placeholder down, and once again, 3 goes into 20 6 times, minus 18, 2 again. Bring down my next 0 placeholder 6 times, again 6 and 6 and over and over and over. So once again, I have a repeating pattern. 2/3 is represented by the decimal 0.6 repeating. Okay, and so I think you get the idea here. So let's just throw in a few mixed numbers and we'll call it a day. So before I actually write this as a decimal, I have 2 options. I can either change this to an improper fraction, 2 times 3 plus 1, 7/2, and divide. Or what I can do is I can just say 3, and then I need to find the decimal version of 1/2. Now most of us already know 1/2 is 0.5. This part represents the 0.5. This represents 3 full units. So I can do it 2 ways. So I prefer the easy way. 1/2 is just represented by 0.5, so 3.5 and 3.5 are the same thing. But if I want to just divide 1 divided by 2, I'll show you why it's 0.5. 2 does not go into 1, but it does go into 10 5 times evenly. 5 times 2, 0. So 1/2 is essentially 0.5. But if I wanted to do a little more work, I could change this to an improper fraction, 7/2. Let's see if we get the same answer if I do it this way. 7 divided by 2. Now I know 2 goes into 7 3 times. Minus 6 is 1. Let's put a little placeholder here so I have a remainder. And I'll go with the 0. 2 goes into 10 5 times. Oh, lucky there, boys and girls. I still got 3.5 either way I did it. So you have options here, okay? Whichever way makes more sense to you, by all means, you may do it that way. All right, if it's a negative number, once again, that only means that my outcome will be negative instead of positive. So let's do it both ways. Now I can just keep my -4, my whole part, and I can just figure out what 3/5 is as a decimal and add it on the end. So let's start with doing it that way. 3 divided by 5. Now 5 doesn't go into 3, unfortunately, so we need to put our little decimal place right there. And 5 does go into 30, 6 times. So I'm just going to do a little subtraction, no remainder, so I know that 3/5, this fraction 3/5 is represented by 0.6, but I also have this -4 in front. So -4.6 would be the actual decimal represented by -4 3/5. Or, if you like to do the improper fraction thing, change it to an improper fraction. 5 times 4 is 20, plus 3 is 23/5. If I divide 23 by 5, we should get the same answer, -4.6. 5 doesn't go into 2, but 5 does go into 23 4 times. And so I know I'm going to need a little placeholder here. I'm going to subtract my 20 and bring down my 0. 5 goes into 30 6 times. And as you can see, I will remain with no remainder. And either way I do it, because this value started as negative, we need to make sure our answer is negative. I have -4.6. Okay? And to shorten this video up a little bit, because I know you're done listening and talking to me, let's just do a little code, and we'll see who is paying attention and actually listening to the video. Let's all do 4/7, but I don't want you to just finish 4/7. I want you to actually do it. Let's do it on the back page in the top right-hand corner. So if you're listening to this video and you did 4/7 where it says number 9, then you didn't do it right. I want you to divide 4 by 7 on the back of the top right-hand corner of the back of the page. So flip your paper over, do 4/7 as a decimal in the top right-hand corner on your own. That's what I'll be checking for. Make sure you do it. I hope you're listening. Don't tell your classmates if they weren't listening, and we can all laugh at them later together. All right, that's it for today.